In the winter of 1864, inside a tiny metal cylinder submerged in freezing waters, 9 men were staring into total darkness. They weren't leaking. The hull was perfectly sealed. But they were trapped at the bottom of the ocean, running out of air. This was the H.L. Hunley, the world's first combat submarine. It had just become a floating iron coffin. The tragedy of early submarine warfare wasn't a lack of courage. It was a failure of physics. Humanity understood how to build ships that stayed on top of the water and anchors that dropped to the bottom. But building a machine that could choose to do both required solving an ancient mathematical riddle. To understand why these early submarines kept turning into graves, we have to travel back 2,000 years to ancient Greece, where a king suspected his blacksmith had cheated him, and a lone mathematician named Archimedes was given an impossible deadline to prove it. To solve the king's riddle, Archimedes had to look at a paradox we still see in daily life. If you drop a tiny pebble into a lake, it sinks like a stone. But if you place a 100,000-ton cargo ship made of solid iron on that exact same water, it floats. Why does nature let a mountain of steel swim while it drowns a tiny piece of rock? The answer came when Archimedes stepped into a full bathtub and watched the water spill over the edge. He realized that the universe is crowded. When any object enters water, it has to steal space. It physically pushes water out of the way. This is fluid displacement. But water is stubborn and pushes back with an upward lifting force. This lifting force is exactly equal to the weight of the water that was pushed out of the way. If the water you displace weighs more than you do, you float. This introduces the ultimate law of density, how tightly you pack matter into a space. A solid square block of metal packed tightly with atoms has high density. It takes up very little space but weighs a lot, so it sinks instantly. But if you stretch that exact same metal block wide into a big, hollow bowl shape filled with empty, low-density air, it floats beautifully. The ocean doesn't see heavy iron. It sees a giant bubble of air and holds it up proudly. This hollow bowl concept is the exact secret behind how humanity finally conquered the deep ocean. A submarine isn't just a machine, it is a giant, engineered iron bubble. By keeping the massive interior hollow and full of low-density air, engineers figured out how to make a 100-ton steel cylinder weigh less than the water it pushes out of the way. But unlike a simple bowl, a submarine has to do something far more dangerous. It has to change its density on command. To sink, the ship opens valves in its belly, flooding special compartments called ballast tanks with heavy seawater. The ship's total mass increases, making its overall density greater than the ocean. It drops beneath the waves. To rise back up, the crew blows compressed air into those same tanks, forcing the heavy water back out. The volume stays the same, but the mass drops. The ship becomes less dense than the sea, and the ocean's buoyant force lifts it safely back to the surface. But the early inventors of the Hunley forgot about one organic, invisible variable: the human lungs. As those 9 men sat trapped at the bottom of the harbor, waiting for rescue, they kept breathing. They were converting oxygen into carbon dioxide. In a perfectly sealed iron box, as carbon dioxide levels rise and temperature drops, the chemical density of the air inside begins to shift. In a machine where buoyancy is balanced on a razor's edge, the shifting density of the air inside doomed them. Their manual pumps simply didn't have the physical power to fight the heavy pressure of the sea. Today, modern nuclear submarines weighing up to 19,000 tons cross the globe under polar ice caps for months at a time. They don't sink into iron coffins because automated computers constantly calculate the exact density of the surrounding ocean, adjusting the ballast down to the microscopic milligram to keep the ship perfectly balanced against the forces of nature. Whether it is a tiny pebble drowning in a lake, or a heavy steel anchor gripping the seabed, or a 100-ton steel submarine navigating the abyss, nature treats them all exactly the same. They are all playing the exact same game of density and displacement discovered by a lone mathematician in a bathtub 2,000 years ago. The laws of physics aren't trapped in your textbooks. They are the silent, invisible architects running our entire reality. Look closely enough at the smallest things around you, and you just might see the laws of the entire universe looking right back.